Hello, this is Team 99, Chinmay Valinskar, Om Kakre, and Saurabh Bansode. Our project is gender identification. To give some background about this project, our aim was to develop a neural network model that can accurately predict gender based on images. We do this by utilizing the power of deep learning, especially convolutional neural networks, and and we train our model on a very large data set that has facial images. We believe that gender identification plays a crucial application in regards with healthcare and security. In healthcare, it aids in uh, diagnosing, planning treatments, and research and enabling more effective and personalized interventions. In security, however, accurate gender identification enhances surveillance and access control, resulting in safer environments. These are some of the definitions of the terms that we have used through the project and will be using through this presentation. Before starting this project, we did literature survey in that we reviewed a paper by Shu Yang um, for advanced face detection with a deep network achieving 90% recall on FDDB. And another study that we looked at was done by Itaya Rani that used a gender recognition system using Gabor features and reinforced local binary patterns, achieving more than 97% accuracy on databases like LFW and FEREC. Now let me talk about the data set that we have used for this project. The data set that we used was obtained from Kaggle and it is named Celeb Faces Attribute Dataset. It's a large data set with more than 200,000 celebrity images with more than with more than 40 attribute annotations. The images in the dataset cover large pose variations and background clutter. Hence, it is an ideal database to train such a model. There are around 10,000 number of identities comprising this dataset. These are the libraries that we have used. These are the tools that we have used to complete this project. We have used NumPy pandas for data manipulation. We have used matplotlib for plotting the data, and we've used TensorFlow to build a neural network.
Hi, this is Om, and I'll be talking about the pre-processing part of our code. So we split up the data set into training, validation, and testing. And in the training set, we had around 12,000 images. For validation and testing, both we had 3,000 images to create a good balance in data. Furthermore, we use data augmentations to enhance the robustness of the model by creating variations of the original images, that is, by altering angles, sizes, and positions, which helps the model become more generalized to the images and helps with prediction. Next, we'll talk about the methodology. So first, we import the dataset images and resize into uniform size of 178 by 218 pixels, and we pass it through a ReLU function and other layers to compute the volume, and later on we pass it through our not ours we pass it through Inception V3 model, which we'll discuss in the further slides. So Inception V3 model architecture is given in this image, where it's a very complex architecture which uses convolution, average pool, max pool, and dropout, and other such layers to compute. And this is the experimental results. As you can see in the baseline, we were getting around 88%, but at this point, we are getting around 93.96%, which is a good one. And to conclude this presentation, so on average, we are getting 94% accuracy. And for further generalization, we plan to add a few layers, which will be seen in the further stages of the project. And This will help, this project aims to help healthcare and security systems. Thank you so much.